Hi guys, do you know what is EV's car? Let's go. I will introduce to you what is EV car.
Hello, this is our team member, Nurul Natasha binti Kamaluddin, Armida binti Momin, and Nurul Sayazila binti Jeffrey.
Hello, good day everyone. Today we are going to talk about the application of electricity and magnetism in EV's car, also known as electric vehicles. Do you know, EVs are becoming more popular now because they are more cleaner and more environmentally friendly than conventional cars. Instead of using fuel, EVs use electricity that's stored in a battery to power an electric motor. Electricity and magnetism play an important role in how EVs work. They help convert electrical energy into movement, which allows the car to move. So, in this presentation, we will explain to you how electricity and magnetism apply in the EV's car, how the regenerative braking system works, and what is the benefit and the challenges of this technology. So, do you know what is an EV? EV or electric vehicles are cars and trucks that run on electricity instead of gasoline or diesel. Main component of an EV is battery pack, electric motor, inverter, charging system, and controller. Example, Nissan Leaf, Tesla Model V, and BYD Seal.
Hello everyone, and I'm Armida. Now I will explain how an electric motor works in electric vehicles. So the electric motor is one of the most important component in EV because it converts electrical energy into mechanical energy. And then the operation of the motor is based on the principle of electromechanism. For example, when electric current flow through a wire coil, a magnetic field is produced around the coil. Inside the motor, this magnetic field interacts with permanent magnet or other magnetic fields. According to the motor principle, when a current carrying conductor is placed in a magnetic field, a force is generated. And then this force causes the rotor inside the motor is rotate, and then the rotational motion is then transferred to the wheels through the drivetrain, causing the vehicles to move forward. And then in the simple terms, the battery supply electricity, and then electricity will create a magnetic field, and the magnetic field will produce force, and the force make the motor spin. As you can see from the diagram, which is electricity and magnetism work together to power an electric vehicles. So electrical energy from the battery create a magnetic field inside the motor, which produce force and causes the motor to rotate. So this is rotation is then transferred to the wheels, and then allowing the vehicles to move forward. Next, let's look at the energy conversion process in electric vehicles. So energy in EV undergoes several transformations before the vehicles can move. First, energy is stored in the battery as chemical energy, and then when the drive passes the accelerator pedal, the battery converts this chemical energy into electrical energy. And then the electrical energy is then supplied to the electric motor, and then the motor converts the electrical energy into mechanical energy through rotational motion. And finally, the mechanical energy is transformed into kinetic energy, which is moved to the vehicle forward. So this energy conversion process is highly efficient because electric motor can achieve efficiency level of over 90%. So as a result, electric vehicle with a less waste less energy compared to conventional vehicles that use internal combustion engine. So, electricity and magnetism play a crucial role in the operation of electrical vehicle. The electric motor uses magnetic force to convert the electric energy into motion, while the energy conversion process allows the vehicle to move efficiently.
Now, let's move to the anatomy of an EV. The physicist duality drive vs brake and Faraday's law in action as regenerative braking. Now we go through one by one. Inside the EV, we have controller as the brain, electric motor, inverter as the gatekeeper translating DC current to AC current, and we have charging system, the intake port for external electrical power, and lithium-ion battery pack, the chemical storage valve spanning in the floorboard. Now we move to the physicist duality drive vs brake. During drive mode, the energy will flow from electrical to kinetic, and the hardware function acts as an electric motor. Physics principle that related is electromagnetic force, and current in a magnetic field creates motion. Where brake mode, the energy flow is from kinetic to electrical, and the hardware function acts as a generator. Physics principle that related is Faraday's law, and motion through a magnetic field creates current. Now we move to the Faraday's law in action, regenerative braking. When the brake is pressed, the motor temporarily becomes a generator. Kinetic energy from the wheel spins the rotor. Through electromagnetic induction, this movement generates electricity which is sent back to the battery. It conserves energy, increases driving range, and reduces brake wear.
To begin with, electric vehicles offer several notable advantages. First and foremost, they produce zero tailpipe emissions, which helps significantly reduce air pollution. Second, electric motors are highly efficient, often exceeding an impressive 90% efficiency. Third, EVs require less maintenance over time because they have fewer moving parts than conventional internal combustion engines. Additionally, it is worth noting that EVs operate more quietly, thereby reducing noise pollution. Finally, the feature regenerative braking, which helps recover energy that will otherwise be waste. However, despite these benefits, electric vehicles still face several challenges that we cannot overlook. One major challenge is the relatively long charging time required, especially when compared to refueling a conventional vehicle. Another challenge lies to the limited driving range of certain EV models. On top of that, battery production can also be quite expensive due to the high cost of lithium and other essential materials. Furthermore, we must acknowledge that charging infrastructure are still developing in many countries. Therefore, these challenges must be addressed effectively to encourage wider adoption of EVs in the future. Looking ahead, the future of electric vehicles is undeniably very promising. Currently, researchers are actively developing first, much faster charging technologies, second, long-lasting batteries, third, advanced solid-state batteries, fourth, wireless charging system for the battery convenience, and finally, as well as smart vehicle integration. At the same time, governments around the world are also promoting EV adoption through various incentives and environmental policies. Ultimately, as technology improves, EVs are expected to become much more affordable, efficient, and accessible for everyone. Thank you.
In conclusion, electric vehicles are a practical example of how electricity and magnetism are applied in modern technology. Electric motors use electromagnetic forces to convert electrical energy into motion. Regenerative braking uses electromagnetic induction to recover energy and improve efficiency. These technologies contribute to cleaner transportation and a more sustainable future. As advancements continue, electric vehicles will play an increasingly important role in reducing dependence on fossil fuels and protecting the environment. Thank you for listening.